I have no idea who watches my videos. I hope you guys do when you need help, but otherwise. Okay, are you ready to start the lesson? Because I already pressed record. Okay. Yeah, I did. Okay. Do you remember how to do this? No. Oh, yes. Yes, how do you do this? They have to multiply that and add to the multiply it to be the end, add to be the middle. So what is the answer? X plus 1, x plus 6. Okay. I know that the answer is x plus 1, x plus 6. And I could figure out for sure if that was the answer by checking it, right? By, right? I don't even have to write anything down. I can do all that in my head, right? X squared, 6x and 1x is 7x, and then 6. So yes, that's the right answer, right? Okay. So what I would like to show you today is we already have this problem set up for us right here. We already know what the answer is. Today what we're going to talk about is when the leading coefficient is not 1 and how to do that. Okay. Now I know that in Algebra 1 you did this. I know that because it's in the TEKS, and I know you're Algebra 1 teachers, most of you, and I know they follow the TEKS. Okay, so I know you've seen this before. I'm going to pretend a little bit like you haven't, okay, and just make sure we remember all the steps to factor a trinomial when the leading coefficient is not 1. Okay, now the thing about it is I call this method the AC method. Okay, there's other names for it. Some people do the box method, which is pretty much the AC method. Okay, and if the way that I'm showing you, like I said, is calling you the AC method, and that is not the only way to do this. That's what I want you to understand. Just because this is the way I'm showing you doesn't mean it's the only way. Just like some of the other stuff that I've talked to you about, okay? Here's the difference. Was talking to a student who graduated last year who is in a pre-calculus class at Texas A&M this year, okay? And they were talking about factoring. And the professor said to them, how many of your teachers taught you the AC method or the box method? And like half the class raised their hand. Now there's like 250 people in her class, okay? Because that's how big classes are sometimes at A&M and UT and Texas Tech and stuff like that, okay? But like half the class raised their hand. Well, he said to the other class, how did your teachers teach you how to do this? Well, by guessing. Guess and check. There's a method called the guess and check method, and you just kind of guess and try to figure it out. Well, things like this, it's pretty easy to figure out, right? But not when the leading coefficient is not 1. That can be really hard if you don't have a method. So if you use the box method as opposed to the AC method, that's fine because you have a plan of how to do this. Okay? Does everybody understand that? So I just want to make sure that we're not just guessing to figure out the answer. I want us to have a method, a process that we go to so that we don't think this is really hard. Because in the end, it's not just a puzzle. We can solve puzzles. We're good at it. Okay? So let me take you through the method on this particular problem because both AC and box work every time. This only works, the way we talked about yesterday, only works if the leading coefficient is 1. Okay? But I want to take you through the process of this and make sure that we all have a way to do this that's not guessing. Is everybody okay with that? Okay, so here's the steps we're going to follow. All right. First of all, the first step we're going to follow is to find AC and B. Well, in order to find AC and B, you have to remember what the standard form of a quadratic is. ax squared plus bx plus c is the standard form for a quadratic, which means a is what? 1, b is what? 7, and c is what? Okay, so if I'm trying to find AC for this particular problem right here, what is it? Well, what am I asking you to do with a and c? Multiply them, right? What is 1 times 6? Not hard, is that? No, this is where you say no. Okay, excellent. Okay, what about B? 7. I just look for that one, don't I? Okay. Now, the same kind of process that we said yesterday, we have to have two numbers that multiply to be AC and add to be B. Doesn't that sound familiar from yesterday? Yes. Okay. So what two numbers multiply to be AC and add to be B? Okay, do those notes make sense? What multiplies to be AC and adds to be B? That's our next step, right? Okay, so 6 and 1 is what we decided on, right? Now, this is where it changes from yesterday. Okay, we're going to rewrite the problem. Now, here's how we're going to rewrite it. X squared plus 6x plus 1x plus 6. How did I rewrite that problem? What did I decide multiplied to be 6 and add to be 7? 6 and 1, right? So I wrote 6 and 1 instead of writing 7. So I took that middle term and split it into two parts. Guys, how do you factor a polynomial with 4 terms? How do you try? By grouping, right? You guys were really good at that when we did it the other day. So our step number 4 is to factor by grouping. Well, what's common in these first two terms? X. What's left over if I divide out an x? X plus 6. What's common in these second two terms? A 1, because I have to factor something out, don't I? What's left over if I factor out a 1? X plus 6. Now, this is a term and this is a term, right? What's common in those two terms? Will it always be what's in parentheses? As long as they're the same, right? They've got to be the same. If they're not the same, I can't factor by grouping, can I? Okay, but I really want them to be the same because that's what's common. And what's left if I take out what's common? Look, physically cover it up with your fingers. What's left? X plus 1. Do you see that? Okay. Wait, didn't we say the answer was x plus 1, x plus 6? Yeah, look what I got. Now here's the deal, guys. If our leading coefficient is 1, do I want to do it this way? No, I don't. That's too many steps. We know a faster way. Okay? We want to choose the best and wisest way that we know. And in this particular case, it's going straight to the factors, right? But this is the process that we need to choose in order to make sure we get the right answer when our leading coefficient is not 1. So why did I do this problem if there's a faster way to do it?
Because it was
Easy so you understand the steps, right? We already knew the answer, so the answer wasn't the focus, it was the process. What's step number 5? Check. Do we have to write it out when we check? Once again, we can do that in our heads, right? Okay? Now, we did it already, but we can do it. I'll model that for you, checking. X squared plus 1x plus 6x. Well, 1x and 6x is 7x. And then 6. So that is the correct answer. Okay? Any questions so far? Okay. Then let's go right into it. 6x squared minus 13x minus 5. Step number 1. Find AC and B. Well, AC is 6 times negative 5, negative 30, and what's B? Yeah, that one's definitely not hard, right? You just look. So, what multiplies to be AC and adds to be B? 3 and 10. What kind of 3 and what kind of 10?
It's negative 15 and positive 2.
Negative 15 and positive 2, right? Now, some of you try to do that in your head, which I totally think is absolutely fine. But when you start to struggle, there's literally no shame in starting this thing, is there? Because you realize, oh wait, it is 2 and 15, right? So now we figured out what multiplied to be AC and added to be B. Now we need to rewrite the problem. 6x squared. What am I going to write? Minus 15x plus 2x minus 5. Now, step 4, factor by grouping. What's common in these two terms? 3x. If I factor out a 3x, what's left? 2x minus 5. Okay, somebody else. What's common in the last two terms? 1. What's left if I divide out of 2x minus 5? Okay. What I meant to say is what's left if you factor out of 1, but I just told you the answer apparently instead of just, sorry about that. Okay. What's common in these two terms? 2x minus 5. And what's left over if I factor out of 2x minus 5 from each term? 3x plus 1. Can I show you something real quick?
Yes.
You don't have to write this down if you don't want to, but let me show you something real quick. What if I would have said this? 6x squared plus 2x minus 15x minus 5. See what I did? Are you positive it would be the same thing? Well, can I show you? Common in these is 2x. What's left is 3x plus 1. Common in these two is what? Negative 5. 3x minus 1. Excuse me, plus 1, thank you. What's common in these two? 3x plus 1. 2x minus 5. Are those the same?
Yes.
So it doesn't matter what order we split the middle term into. No, I just needed to make sure you knew that. You okay with that? Okay. Ready for another example? Okay. 6x squared, plus 9x minus 27. Step 1. AC and B. So AC is 162. Negative 162. And what's B? 9. Okay. Okay. I don't know all my factors of 162, so I'm going to have to write stuff down. Okay. 1 and 162, 2 and 81, 3 and 54. Okay, let me ask you a question real quick. I need to talk about your numeracy. We talked a little bit about it yesterday, your comfortableness with numbers. Some of you are using calculators to do this. Some of you are doing this in your head. Which one do I prefer? I'm okay with both. Okay? I'd like us to be able to do stuff in our head, but I'm not going to demand it. Because some of us are good at math or math skills, but maybe not our multiplication skills or division skills. Is that fair? Okay? But here's the deal. Do you know how to tell when things are divisible by certain other things?
Yeah.
There's some tricks, and I want to make sure you know. And if you already know them, I would like you to not say them out loud. Is that fair? Okay? I mean, unless I ask. Is that okay? Okay. So, how do you tell if a number is divisible by 1? I'm just teasing. That was just a joke. Okay? How do you know if a number is divisible by 2? If it's even. If the last number is divisible by 2, right? Basically. Do you know how to tell if a number is divisible by 3? If all the digits add up to a multiple of 3. Right? What's 1 plus 6?
7.
Plus 2? 9. Is 9 divisible by 3? Yes. Then so is this number. Is that something new to you?
Yes.
Well, good. That's awesome.
How old when you figured this out today?
Okay, so here's the deal. If a number is if the last digit is divisible by 2, we know the number is divisible by 2, right? Do you know how to tell if a number is divisible by 4?
If it's even.
If the last 2 digits are divisible by 4. Is 62 divisible by 4?
Yes.
No. 60 is divisible by 4, so 62 is not divisible by 4, right? So this number is not divisible by 4. How do you tell if it's divisible by 5?
If it ends in 5 or 0.
If it ends in 5 or 0. How do you tell if a number is divisible by 6?
They add up to. What is it by 5? They add up to 6.
Nope, it's not like that. It's like this. If a number is divisible by 6, it's divisible by 2 and 3. Because 6 is divisible by 2 and 3, right? That's not how it works for everything, but it is how it works for 6. Okay? Is this number divisible by 2 and 3? then it's also divisible by 6. So what's the factors if I divide it by 6? 27. Okay. What about 7? Okay, here's what I know about the number sense trick about dividing by 7. I don't know it. I got taught it once, and doing the trick for me was faster than just dividing it by 7, so I never remembered it. Does that make sense? There is some sort of trick, but with a number like 162, it's faster to just try to divide it by 7 and see if it works. Does that make sense? What you got? No, I can't stop there, because 6 and 27, I can't get 9 from that. I'm trying to figure out a 9, right? And 6 and 27 don't follow each other in the counting. Okay, I realize there's a 6 here and a 27 there, but that's not how I know I can stop. Okay, I either stop when I get the answer, or I stop when these numbers are either super close, like if they're one right after the other, or if no numbers in between them can divide into whatever number. Okay, so 7, does 7 work? Can you is this number divisible by 7? If I divide it in, it would be a 2 first, and with 2 left over is 22 divisible by 7. So then this number's not divisible by 7. What about 8? Do you know the trick for 8? Okay, see if you can figure out the trick. Okay? If it's 2, the last number is divisible by 2. If it's 4, the last 2 numbers are divisible by 4. If it's the last 3 are divisible by 8. Well, that's not really a trick here, because this whole number is it's just 3 numbers, right? Can you tell if this number is divisible by 8? It's not, right? Because if I divide it into 16, there's no remainders, and 8 doesn't divide into 2. So 8 doesn't work. What about 9? Do you know the trick for 9? It's really similar to the trick for 3. 3, if I add this up, and that number is divisible by 3, right? 9, add up the digits. If that number is divisible by 9, then this number is 9. And it is. So what is it? 9 and what? 18. Okay? Now, there may or may not be other factors of 162, but we don't need them. We don't have to care about them, do we? Why? 9 and 18 is what I need, isn't it? Okay? What kind of 9 and what kind of 18? Negative 9 and positive 18. Okay? So, step number 3, rewrite the problem. 6x squared plus 18x minus 9x minus 27. What's common in the first two? 6x. Factor it out. What do you have left? X plus 3. Okay. What's common in the last two? How about negative 9? Is that okay? What's left? X plus 3. Because I factored out a negative 9, remember? Okay. And so what's the answer? X plus 3, 6x minus 9. Okay, so what I meant was, what's the answer? Because we're not done yet. Normally, when we get here, aren't we done?
Yes.
But guys, what do you notice about the second parentheses?
6x.
6 and 9. There's a common factor in that parentheses, isn't there? Isn't there 3? So I could write it like this. Oops, 2x minus 3. I don't like that 3 there. Where does it usually go? At the front of everything. But I went ahead and put it there because I wanted you to know I was factoring it out from the 7. But guys, that's a problem, isn't it? Because normally when I get here, I'm done and I'm going to stop and go to the next problem. I'm not going to really always think to look for common factors to take out again, right? So this is the part that sometimes you're mad at me about, and I accept that. Guys, wouldn't it have been easier if from the very beginning I noticed that all 3 of these numbers were divisible by 3? So shouldn't our list of what to do really start with 0.5? Factor out a GCF. Yeah. Shouldn't we do that first?
I think I saw this earlier.
Yeah, I was. Here's the deal, guys. If we would have factored out a 3 from the very beginning, I would have had 2x squared plus 3x minus 9. Oh, geez. Look at my AC now. Negative 18. Look at my B, 3. When we have had to do a whole lot less work here, factor out a GCF first. Okay? I want to take you through this problem real quick because I need you to see something real quick, okay? Multiplies to be negative 18 and adds to be 3. 6 and 3. What kind of 6 and what kind of 3? 6 and negative 3. So 2x squared plus 6x minus 3x. Whoa, minus 9. I don't know what happened with that x. Please pardon that x. Now I'm still dragging this 3 along with me because it's a factor and I got to be there. I just cover it up so I don't get confused. Common in those two is a 2x. So I have x plus 3. Common in those is a negative 3. So I have x plus 3. Common in these two is an x plus 3. What's left over is a 2x minus 3. Guys, look, it's the same answer. That one was just a whole lot easier, wasn't it? Okay? So please don't forget to take out a greatest common factor first. So why was I horrible and made you do it the long way first? It's not part of my text, but that's a good guess. I want you to be problem solvers. Okay? I don't want you to be quote-unquote calculators. I don't want you to just sit and press buttons all the time. I don't want you to sit and just regurgitate what I've just told you. I want you to figure out stuff. Okay? Here's the deal. I'm still going to get the same answer. These answers are the same. This one's just easier because the numbers are smaller. Look at the problem. Is there a greatest common factor? Take that out first. What do they say? We want us to work harder. I mean the other way, right? We want to work smarter, not harder. Okay? We still got the same answer, right? But let's work smarter and not harder. Okay? All right. On the worksheets, these are the problems I want you to do. Okay? Factoring quadratics B, I want you to do problems 5, 7. You guys are pre-AP, so I want you to do 15 and 19. If you're watching this and you're not pre-AP, you don't have to do 15. Okay? On the back of that page is factoring quadratics A, and I want you to do 1, 5, and 8. That's the side that starts with 2x squared plus x minus 15. I was apparently feeling ornery this day because the third worksheet is also called A for some reason. Okay? And it starts with negative 2x squared plus or minus 13x plus 7. On that page, I want you to do 4, 8, and 20. Okay? Any questions?
No.
Okay.